everyone. First of all, thank you so much for joining. Welcome to this webinar. My name is Anand, and I'm the Chief Product Architect at B-Yond. I'm really excited to welcome you all to this webinar, which is in fact our third webinar in the series of generative AI and telecom. And of course, we have another track on topics centered around 5G, AI, and network packet analysis. So if you haven't had a chance to watch those, if you'd like to get access to those webinars, please check out the resources tab on B-Yond.com. And of course, for today's webinar, I'm joined by Patryk Debicki, who's the Vice President of Solutions Development at Realize. Patryk has immense experience in the network automation space. And in fact, today he will be walking us through a practical guide of how Gen AI and large language models are eliminating barriers to knowledge. If you look at it in the dynamic landscape of the telecom industry, the integration of Gen AI and LLMs represents really a transformative force, addressing a lot of key pain points and changing the way knowledge is accessed and managed, right? A particularly impactful aspect is the capability to seamlessly combine internal data with external documentation, along with logical association of data that's sitting right in front of you, to provide what's a holistic approach to information utilization. So while automation still remains a priority in the industry and AI is helping scale what engineers do best, this capability that Patryk is going to explain today, he's going to walk us through some of the LangChain frameworks. So this capability improves access to comprehensive information and knowledge bases, enabling telecom experts to make more informed decisions, troubleshoot more effectively and faster, and optimize operations at scale. So for all of you tuned in, sit back, relax, and enjoy this webinar. And please help me welcome Patryk.
Thank you very much, Anand. It's a pleasure to be here today. So let me start, and I'm gonna start with agenda. So what we're gonna be talking about today, I'm going to talk a little bit about the background around the LangChain, which is framework that allows to build quick LLM applications, and I will explain what type of problems this framework is solving. We're gonna go through a few use cases. We'll explain how these use cases work with a demo, and also we'll explain it with the step-by-step explanation of how the call flow looks like for this type of an application. Of course, we cannot miss out on the considerations that relate to this type of applications using the LangChain framework, and we will conclude with Q&As. So let me start with explaining the title. So eliminating the barriers to knowledge. So if you think about the LLMs, they are trained with about 300 billion words, which is an immense amount of information. If you wanted to visualize it, take, for example, you know that it is about 500 words per page. It's going to be around 600 million pages. And it would take for a human to read it for a millennium, assuming 1 minute per page reading non-stop. So there is loads of information that could be interpreted. However, LLMs, they lack genuine understanding in a human sense, and they also hallucinate. What it means that they can provide incorrect or biased or incomplete information with a false sense of authority. Yeah, if you have been using ChatGPT, you know how well the answers are structured, and because they are so well structured, yet not all of the information is correct, it could get the sense of this false authority. And also the LLMs are trained with the information up to a certain point of time. They are not being constantly retrained as the new information comes in. And retraining LLMs is quite a resource intensive and costly process. So on one side, we've got a lot of knowledge. On the other side, we have the barriers. Now, harnessing the LLM intelligence requires some strategic methods in order to unlock the access to that information. So we're gonna be showing how LangChain utility, that is a framework and designed to break down the obstacles, can be used in order to leverage and build LLM-based type application. So because of this simplicity to use and the capability to integrate with different type of LLMs models that are available, there's been a lot of hype as well on the internet and on the news. And if you're gonna be, looking and browsing through the news that are available, if you just Google about the LangChain, you're gonna be seeing plenty of hype related what type of things LangChain can integrate with. It can integrate with Redis, with Streamlit, with Snowflake, and on and on. So it is a very, very hot topic, and for a reason.
That's very, very interesting what you mentioned, Patryk, right? I mean, it's kind of as I mentioned in the introduction, and as you also alluded to, a lot of really benefits that one can see from LangChain and potentially where you can apply it to. But can you also shed some light on what types of problems is LangChain solving?
Yeah, so basically, I categorized this type of problems into 3 areas. One area that is related to complexity of development, another with LLM enhancement to the limitation associated with the LLMs, and the last one is with regarding speed to deploy and maintenance this type of application. So on the workflow complexity associated with LLM utilization, it gives certain functions that allow you very well engineer the prompt. That is very important from the LLM perspective. It gives you certain integration management function, debugging. On the LLM capability enhancement, it's also integrated with ease to implement things like embedding vector database that are targeted to utilize the local information and create a context when we ask questions to the LLMs, and it allows as well to leverage the LLM reasoning capabilities. And on the last side is this debugging and maintenance. There are certain type of tools and capabilities that actually, when you build the application, you can see step by step under the hood all the questions, answers, and allows you to well understand how these things are being how they stream the information across different components of the LangChain framework.
So that's pretty great. But it's interesting to look at different verticals where LangChain can help bridge the gap. But there seems to be a principal engineer problem in the industry, Patryk. Where the domain knowledge is contained, under a certain amount of expertise, and that's where the cost to acquire that knowledge across many different domains, as you know, the telecom landscape, or for that matter, any industry, right? There are so many different verticals, domains, and areas of expertise. So how do you facilitate that seamless knowledge transfer across all these different verticals, right? So how can LangChain address that so that the cost of knowledge at least becomes close to near zero?
Yeah, so I think that's the use cases that we would like to talk about today. Addressing this principal engineering problem means the problem behind it, as you rightly said, it is the scarcity of the expert resources, and they are also very expensive to and very difficult to hire, and they create a bottleneck normally because a lot of people require the knowledge, and there are inefficiencies associated with it, because if they need to be doing the work, but because they have the knowledge, because they implement things, it is only them that can answer certain type of questions. So and we don't want them to be spending time answering the question. We would rather take the knowledge, create a knowledge database, or take the documentation, put it in a single place, and be able to access this information and break the silos that are created by this approach. So in order to show you some examples of how LLM-based application can address it, we prepared for you, well, a demo and a more detailed analysis. So Anand is going to show you a demo how a chatbot interface can accelerate network packet analysis by asking questions. So you don't need to be, it basically allows you to accelerate time to information, right? Instead of going into the different tool screens, getting to the final destination dashboard, you can just ask a question. And also, he's going to show you how the LLM can be used to interpret the error codes that are being provided as an outcome of the analysis. So rather than trying to look up this error code in different type of documentation, you have the things being integrated within the tool itself. And then I'm going to show you step by step how such application work. I'm going to take another example in here just for the variety. And I'm going to show how such a chatbot works on top of a performance management database. So Anand, over to you. If you'd like to share your screen with a demo.
Absolutely. Thank you so much, Patryk. Happy to take over the screen now. So as Patryk already alluded, I'd like to sort of dive a little bit deeper into a demo of an actual use case where the LangChain framework can be used to integrate seamlessly with, of course, internal data, and of course, and provide feasibility towards external documentation as well, right? So today I'm going to be interacting with Agility, which is, of course, it's a tool that's designed to automate network packet analysis. So if you're talking about the telecom industry, you have a variety of services that are in play. And for each of the subscriber activity that happens either in simulated lab environments or in operations network, there's a lot of network traffic that's being generated at the same time. So in order to be able to quickly deduce failures, to be able to interpret what exactly the root cause is, and then get to vendor documentation or standard documentation takes a whole lot of time, right? So that process essentially is simplified by this LangChain framework that Patryk was talking about. So the basis of the interaction is actually network traffic being analyzed in near real time. And the output of that is what we're going to interact with, right? So seamlessly asking some questions to get some valuable insights into how the network is behaving. Now, there was an extensive webinar that I did on this specific topic of how one can perform packet capture data analysis. So if you haven't watched that, please feel free to check out the website. So typically, as Patryk was mentioning, troubleshooting sort of resides in a specific expertise, right? So as somebody who looks at network traces and data points to be able to deduce root cause information. So that's essentially what the framework is facilitating, is cross-domain knowledge, right? So let's say ideally, I would have to be very familiar with the network itself, understand the data itself, understand troubleshooting processes, and then also understand, the tool. Even if AI is in place where it's automating this process, I have to understand that process as well. So now how do I facilitate the same level of conversation through a simple text, right? So this is where I'm assuming that the network traces are being collected and they are being processed in real time, and now they're made available to me. So how do I really interact with that, right? So I have a few questions that I will be interacting with Agility to get some valuable insights. So let's get started, right? Now, let's say I'm actively tracking my network and I want to see the status of the last subscriber activity that was completed. It can belong to any service like a voice service, a data service, a mobility service. So, and there are some sample prompts here, as you can see. So I can just click on one of those and say, hey, can you show me what was the last analysis that was completed, right? And this is where the framework sort of comes into place. And if you're interested in learning how this works in the back end, please feel free to reach out as well, right? Today, we'll not dive into a whole lot of the specifics of how it works, but we'll talk about more of the end result, right? So as you can see here, it produced the answer for me. It said, this is the latest analysis that was completed by you for the EPS fallback services. And from here, I have the option to navigate to it to look at the result. But let's say, what if I don't want to navigate? I want to see more details of what the analysis was, right? So I can say, give me the top 10 failures. For example, let's say I'm interested to look at 10 distinct signatures that are happening in my network for a specific service. So I can say, give me top 10 failures for the service key, because every service is associated with its own unique service key, 5G underscore SA underscore mobility, right? Because that's the service that is analyzing different kinds of EPS fallback procedures in the network. Instead, what I would have to do if this was not present is actually go into each one of those root causes and drill down into what the different types of RCAs are. I'll actually show you that as well. And there you go. The LLM was able to answer that, saying the top 10 failures are as such, right? There are different kinds of signatures, as you see. Some of them are failures, some of them are warnings, and it also tells you how many occurrences of each one of those are happening in your network, right? So that's one example of that. Now, I want to dive a little bit deeper. I want to see which subscribers are impacted in my network, right? I'm actively monitoring some VIP subscribers for which I need to act fast. Or for example, I'm looking at special services like 911, where the time to respond is really, really critical. So let's say I want to look at how many distinct subscribers had failures in the last maybe 3 days, 10 days, doesn't matter. You can input your own timeline. But instead of having to correlate multiple data sources to be able to get to this information, I can put in that prompt and say, okay, it said about 67 distinct subscribers had failures in the last 3 days, right? And then I can also say, give me the top 20, because I want to look at 20 subscribers, top 20 IMSI that had failures in the last 3 days. Okay. So now I want to drill down a little bit further. I want to, at a snap of my fingers, want to look at which subscribers have been impacted, and I can do so. Now, the types of questions that you can ask are tenfold, depending on the types of issues you're looking to analyze, the types of signatures you're looking to investigate into your network, you can analyze those. And as you see, there's a bunch of IMSIs that pop up here, right? I can go into more sort of specific details as well. I can say, now that we looked at, which services were impacted, I can also go into some other details as well, right? So I can look at, let's say, how many services were impacted in this case. So I can say, give me the list of services that had failures in the last 1 day. I want to look at what's happening in my network over the last 1 day. And I want to see whether the voice service was impacted, whether the data service was impacted, depending on what I'm monitoring, right? So I can get that as well. Okay, so it said no services had failures in the last 1 day, which is great, which means my network is looking great, right? All my subscribers are happy, everything is great, right? So these are some of the types of prompts that I can input to actually seamlessly get answers, right? And that's really the framework that Patryk is walking us through. Now, let's talk about the second half of it, which is how does LLMs seamlessly help us integrate with vendor documentation, right? This is one portion of it where I'm looking at signatures, I'm looking at the subscribers that were impacted. But let's say I want to look at the actual error itself, and I want to understand deeper why that failure is happening, right? So I can go to one of the latest analysis that was completed for EPS fallback, right? And here I can actually go into each of these signatures that were generated. As you can see, there's a variety of signatures, successes, there's different types of failures as well, I suppose. So all these call flows are available, right, in my analysis. So I can look at those. Now, let's say I'm interested to look at other signatures that are happening in my network, right, for VoLTE services. So I can similarly put in a prompt for, can you show me all the analysis done for the VoLTE service? And it will lead me to this link, right? And as you can see here, it generates a variety of call flows. There's about 26 different attempts of VoLTE calls in my network. Now, ideally, if that integration was not there, this framework was not in place, I'd have to go through each and every one of these to understand why things are failing and also interpret these errors, right? For example, this one says it's a success warning with a diameter 5102 error, and I'd have to drill down into each one of those, right? And there's, as you can see, there's really a bunch of signatures here. But what LLMs is facilitating here is actually looking up into vendor documentation to help me understand what exactly this diameter failure is, so that I don't have to go, let's say, to the standards or look at some specialized vendor that my network is operating on and things like that, right? So I can seamlessly go to the diagnostics tab, which is where the LLM really integrates with external documentation. And as you can see, it says the requested user data is not allowed to be read in this case, right? Which means that is a clear indication that I need to log into my HSS, because that's where the error is coming from. And I need to check the details as to why, if there's some call barring active on this user and things like that, or some kind of provisioning that needs to be fixed. Similarly, there are other multiple signatures that I can go into, right? I can also go into what's happening in my Warner network. I can look at different kinds of failures. For example, this is a diameter 5001 error, unknown subscriber that's popping up. So same thing. And in this case, the LLM was able to give me 3 different types of interpretations around this error. So it's helping me quickly get to the root cause, saying that this message was received for a user for a wildcard entity that is not known, and things like that, right? So in short, this is how that entire automation framework is being completed, where LLMs are sort of bridging the gap to knowledge, where I could be a troubleshooting expert. I could be, a fresh engineer that just got onboarded, but I'm still trying to understand what's happening in the network. Through this, I can seamlessly interact and derive different kinds of information. Anything?
Sorry, Anand, sorry to chip in. I just wanted to ask you, so on the source side, you get SP vendor and LLM. So if you could explain, so we have specific vendor documentation that is integrated, but when you get the LLM, does it mean that we have public domain information that we are allowed to go out to the internet?
Absolutely, Patryk. It's exactly as you mentioned, right? Sometimes there's open source documentations that you can access, such as 3GPP. Everything is open source, where you can read the standards and get to know how the standards are laid out. But you also have specialized documentations that vendors can create specifically tailored for that network. So you have very specific configurations that are listed, which can be looked up as well. The beauty of this is that you can potentially integrate with any knowledge base. You can also integrate with tickets, right? You have your ticketing system where a lot of critical information is being documented. You can look at that as well. You have your historical trends and KPIs that you can look up as well. So the framework really facilitates a lot of flexibility of where you can gather data from.
Yeah, and I think this is one of the things that we're going to be mentioning later on when it comes to the consideration, especially around the privacy. So we can, for example, utilize and make decisions if there is sensitive information to only use local information for the information extraction. If it is something that is not privacy sensitive, we could potentially use something that is outside of the of our own domain. And also, I think one thing worth mentioning here as well is, even though, for example, 3GPP documentation is a public domain knowledge, LLMs were not specifically trained on this type of information. They contain the information. And the risk is that if you're going to be relying on the information that sits, within the LLM, there is a high risk of hallucination. So in order to reduce the risk of hallucinations, it is more efficient to gather 3GPP documentation on a local store, first search for specific keys, and only then ask LLM for the interpretation.
Absolutely. Absolutely. I believe I do have some examples where it looks up 3GPP documentations. For example, this is a 5G SA connectivity service looking at how devices connect to the network. As you can see, there's a bunch of signatures here from the 5G session management call flows. And here I would have to have domain expertise to understand signaling transactions in the network, right? So that's where, as you can see, it is looking up 3GPP standards to tell me what exactly this failure is. So hope that answers your questions, Patryk.
Yeah, thank you very much. That's been very good. Thank you.
Awesome. That's pretty much what I wanted to cover in the demo, Patryk, and now I'll pass it back to you to continue further.
Okay, let me reshare my screen. Please let me know whether you can see it.
Yes.
Okay, so let's see how in details how actually such an application works. I'm going to use a different example. This is about integrating with the performance management database and trying to provide a chat type interface in order to understand the issues that are happening on the network. So this is like a high level view of a call flow with LangChain components. So you have a question on the left hand side and an answer. So that's this, whether you're going to be interacting with ChatGPT or with this type of a chatbot, you're still going to get a question and answer. However, the logic and the workings inside are slightly different. So in the middle, you've got the agent, and the concept of an agent in LangChain allows you to utilize the LLM reasoning in order to make certain decisions and decide on the next step of a flow. Within LangChain, what is not pictured here, there are also chains that are like deterministic subsequent actions. Here we're going to be using the decisions and the reasoning from the LLMs. Another element in here, you have the memory, and the memory is very important because it allows you to keep the context of the question and ask follow-up questions. So as you've seen with Anand's demo, he was asking one question and he was asking subsequent question, and it still remembered the context. A vector database is very important because this is place where we keep the local documentation, local knowledge database, vendor documentation, and there could be a number of those. And the vector database allows us to do semantic search. So like in a document database, you're going to be searching for keywords. Here, instead of keywords, the vector database allows you to understand the semantics of the question. And it allows to extract only relevant part of information that can be created as a context into the LLM. And another element in here is a toolkit. And toolkit with an LLM basically allows you integration with other type of tools that you want to interrogate or extract the information from. So in our example, we are going to be interacting with a SQL database. So let me walk you through the details. So you have a number of components in here. So you have user questions, memory that I just explained, going to be keeping the context. You've got the agent that is doing the LLM, that is utilizing LLM reasoning, LLM toolkit that allows to interact with other elements, vector database and SQL database. So we're going to be asking questions like, for example, which part of the network had the largest amount of dropped calls? Or give me top cells with highest traffic today, right? So we can basically ask number of different type of questions that relates to the information within an OSS system. And this question that is coming to an agent is going to be appended to a template. So LangChain has got the concept of templates, and templates are important in order to indicate to the LLM what type of role it should take. And also it could give LLM certain type of hints. So for example, you can tell within template that to the LLM that you are an agent designed to interact with a SQL database. So in such case, it will know that it requires to write a piece of SQL code in order to extract the relevant information. So this prompt is going to LLM, and as an answer, we are going to get a piece of SQL code. And in this SQL code, it is going to provide us a list of tables. The SQL code will basically extract the list of tables from a SQL database. So this code is going to pass on to a toolkit, and toolkit is going via the connector is going to interact with a SQL database. And as a response, we are going to get the list of tables. Now, the thing is that the list of tables, they can mean different things. They are not necessarily type of information that LLM can understand. So before we're going to go back to LLM, we are going to interrogate the information about this table description. So we're going to take this list of tables and we are going to go into a vector database to get the like data dictionary type description of those tables. And only then we are going to pass this information back to the agent. An agent is going to append this information to the previous prompt. So this prompt is going to grow over time, but this prompt will now contain the list of tables and the table descriptions. So now LLM understands, what these tables are about and is able to select which tables to interrogate, and will ask for a schema for the selected tables. And by asking the schema, is going to generate another piece of SQL code that is going to be forwarded to the toolkit and interrogated from a SQL database. So as a result, now we've got the question, we've got the list of tables, we have tables description, and we have schemas for relevant tables for the asked questions. So all of this information is again added to the prompt. So LLM keeps the history of the questions. And now the LLM can construct the SQL query that is going to be relevant to the specifically asked question. So this query needs to be executed on a SQL database, and we're gonna get results from the SQL database back to the agent. Now, these results are again appended to the prompt that is being sent to the LLM. Now, LLM is containing all the context and all information that is needed to answer the question. And this final result is then sent to the memory. So so that we don't need to repeat the cycle if a follow-up question is asked, and also is being sent back to the user. And within the final response and the way the LLM construct the answer, we can also add a link to a specific dashboard within the performance management system. So not only you get a text response, but also you get the link to a specific dashboard. So this is like a simplified view of how these things work. There is a lot of things that I haven't shown. So for example, there is a lot of things that you need to cater for, like, for example, error correction, validating whether the queries are correct, making sure that there are no errors between the, so for example, LLM can make errors when it creates the SQL query. So this error handling is actually embedded in every step of this code flow.
That's excellent, Patryk. Thank you so much for sharing. So based on whatever you shared, right, looks like this is really a silver bullet to accelerate AI adoption, given the framework is flexible. It can allow human-like interaction with machines, given the context that it can understand and capture that in the memory. So it looks like it can bring a lot of things to the table, tangible AI benefits, right? So is it really so?
I think,
And
yeah.
based on your experience, if there are any bottlenecks or challenges that you're seeing, and what are some of the potential other considerations that you have, if you can shed some light on that.
Sure. So there is surely the lang chain and the LLM type based applications are amazing way to show the value of what the LLM can do. But like with everything, right? There are some challenges, there are some limitations. One of the things that we need to determine is there is a difference between the limitations associated with the lang chain as a framework and the actual limitations of the LLM. Some of which are addressed by the LangChain framework itself, as we discussed before. And so LangChain allows you access to different type of LLM engines, and you could be using it with OpenAI, you could be using it with Bard and the Gemini AI, but you could also be using it with internal or your internal open source type LLM deployments, like for example Llama 2. And so not every model with LangChain work very well. Yeah, some gonna be working better, some gonna be working worse. And you need to have a little bit of knowledge and experience to cater for those problems that are coming along, writing an application. Also within the LangChain, you don't get like out of the box security functions, security framework that would allow you to cater for certain type of vulnerabilities. And this is something you need to actually do it yourself. Also, another aspect is, I think this is a little bit more to do with the LLM rather than LangChain itself. But if you use LLM reasoning, it is not a deterministic process, right? LLM can make mistakes, and it is not always going to be, you're not always going to be getting the same answer. So validating those outputs from the LLMs and putting in guardrails in place is extremely important. And this is also to do with the data privacy, business privacy issues as well. There's been a famous case recently where someone managed to convince a chatbot from the car sales company to make a deal for $1. It realized it was ChatGPT behind, so it sent instructions to ChatGPT that anything it says needs to be legally binding, and as a result, he agreed on a deal to get a car for $1, right? So this is this is funny and amusing when you read it on Twitter, but if it's gonna be relating to your business, I think these are the things you really need to think about. Another aspect is time sensitivity, right? So this is you've seen that when we ask the questions, you don't get answer immediately, right? And if you use ChatGPT, if you use Bard, normally it takes a little bit of time to get the answer. And the more interaction you do, the more reasoning you use from LLM, the longer it's gonna take. So for example, in the call flow that I shown you, we had plenty of prompts going to the LLM. And I showed it so that to show you how it works and how you can make it interactive with the LLM. But in reality, if you can decide with rules and be deterministic. So for example, we don't need to be asking ChatGPT to create a SQL query to list the tables. Yeah, we can have it in memory and we can do it straight away. So there is some level of optimization you can do to accelerate and speed up the time to get the responses. But any real-time application, like for example, anomaly detection, cannot rely on the LLM, right? You can still use transformers for the anomaly detection, but you cannot rely on the LLM for certain pattern detection, for example, if you're after real-time applications. So while LangChain is amazing when it comes to building the proof of concept, showing the value, understanding the value of the data, and the building production type industrialized application still requires some professional skills, to cater for all the things that I just mentioned. And then there is the data privacy issue about sending the information out to the internet, leveraging locally deployed LLMs. That's still going to be requiring quite immense resource, but these are the things that you need to cater for, and you need to be very careful how you're going to be sharing the information with the LLM engines that are in a public domain. So I think this is like snippets of I think of issues and consideration that are very important. And then let's go to conclusions. So we have shown how, with the use of LangChain, you can ask questions to a tool that would otherwise require an expert to answer, otherwise would require expert knowledge. And LangChain, with its clear modular design, with the prompt templates, with chains, agents, memory functions, allow to quickly build LLM applications with few lines of code, right? So you really don't need to be writing hundreds lines of code, because you've got, you can import those libraries. Python libraries, it supports Python and Java. So you can import those libraries and you can utilize it. And the LLM-based applications can provide very powerful tool set for the telco operators to resolve a principal engineering problem. There are other use cases, that could be built. You can imagine, for example, integration with the ticketing system. I think Anand mentioned it. Building the local knowledge database, and integrating with certain type of customer bot, customer chat, and so on. And while the concluding is that while it is quick to build prototype, there is still a lot of considerations when building an LLM-based production industrialized application. So that concludes the presentation, and I think we can go towards any questions if we have them on the chat or in the Q&A window.
Awesome. Thank you so much, Patryk. Great webinar indeed. Appreciate you sharing on the topic of how generative AI and LLMs are bridging the gap to knowledge, right? For the folks who are tuned in, we will actually have, before we actually dive into the Q&A, I'd request my technical host, Lara, to bring up the poll questions. I think they're ready to flash on your screen, and kindly help me answer those. And in the meantime, Patryk and I can dive into the Q&A. So, Patryk, we do have a question in the chat. You talked about, actually, in the conclusion slide also you alluded, but there's a technical question, sort of how can do you have an idea of the computational requirements that LangChain requires, right? Or Llama for this purpose?
Yeah, so I think we need to differentiate between the two, right? LangChain is basically a library, a framework that allows you to leverage LLM. LangChain itself doesn't require much resources to be implemented. However, on the, for example, large language model deployment within the private cloud, there is a lot of considerations to take into account, right? So there are different sizes of the model. So you can do the model that has got 65 billion tokens, right? Or 65 billion parameters. And this type of models will require a lot of resources and a lot of memory to use as well, while they are reduced size. So instead of using 65 billion, you can use 7 billion, or you can even use 32,000 parameters that are like scaled down versions of it. Of course, the responses you're going to get are not going to be as good as the ones that are very, very big. But depending on the type of application, depending on the type of documentation you have, we can actually look and decide which model would fit best for a specific use case.
Okay, that's perfect. Thank you so much, Patryk.
But I think the assumption is, for every parameter, you assume like 32 bytes per parameter, right? So you can make calculations, how much memory you'll need for a certain type of LLMs. I'm not, expert myself on dimensioning, but we can avoid principal engineering problem and get into a knowledge database and find it out.
Absolutely. Thank you, Patryk. There's a follow-up question on that. The other vertical after resources is time. So with these kinds of resources that you mentioned, how long would it typically take to train an LLM on 3GPP documentation?
So we wouldn't be training 3GPP. So we wouldn't be training LLM on the 3GPP documentation. It would be a very expensive, a very long process. Instead, what we're doing, we take 3GPP documentation and we use embeddings in order to put the 3GPP documentation into a vector database, right? So what embeddings do, they encode the text into vectors, and those vectors capture the semantic information embedded in each sentence. And we're gonna be chunking those 3GPP documentation in small areas. And then when we're gonna be asking specific 3GPP question, we are going to first find the chunks of documents that relate to specific type of a topic. We're gonna extract this information from the vector database and provide it as a context to the LLM to interpret it for us and answer the question. So this process is called RAG or RAG. It's retrieval augmentation generation. And what it does, it first extracts the information from local sources from a vector database before it's being sent to the LLM for the interpretation. It's much cheaper. It's much more effective way than retraining the whole LLM.
Got it. You actually answered. Thank you so much, Patryk. You answered one of my questions, which I had, is how can you consolidate information across documentation, right? So you have documentation, you have databases, you have
yeah, that's exactly the thing how we're doing. Yeah, so we using embedding and vector database, and vector database has very good, with a semantic search, and it also allows you to quickly get a similarity score. So not only you're gonna get the chunks of information that relate to the question you ask, but also gonna give you a similarity score of how much this chunk relates to the question that you ask.
Absolutely. Thank you, Patryk, and thank you, Carlos, for those questions. Those were great questions. Patryk, I have one more question. During the webinar, you talked about the different types of issues that LangChain is solving. You alluded to 3 of them, right? Can you actually share a little bit more of details as to how that's being made possible? And can you dive into specifics?
Yeah, so I was talking about 3. I think I categorize into 3 areas, right? Development and workflow complexity, LLM capability enhancement, and debugging maintenance. So actually, I've got a slide on that one as well. So this is actually so I would encourage anyone to go on the LangChain webpage. This webinar was not meant to train and tell how LangChain works. It meant to show you how you can leverage this framework to build, certain type of applications. But if you go there, you're gonna see there is a description of how this framework looks like. So you've got observability level, which is called Langsmith. You get number of functions to actually see how your application is working performant. You get Langser for the basically you've got like REST APIs associated with the chains and agents that you create that you can invoke. You've got the templates, library of different type of templates, but you can do the template itself. If you zoom in, you can see, the LangChain contains chains, agents, advanced retrieval strategies. So this advanced retrieval strategies is just what I explained, how we extract the information from the 3GPP. Agents allow you to use the reasoning. Chains allows you to sequence specific type of actions one after another in a deterministic way. So if you know what sequence of the actions need to happen, you're going to be using chains. If you don't know what the sequence, you need LLM agents to provide you this reasoning. You're going to be using agents. Then you've got IO model. So basically, it allows you to simplify the way you ask questions the way you embed questions into the prompt, and the way you interpret the output from the LLM back to the user. So this is like this I/O models. Then you get the retrieval models, retrieval functions that give you, specific capabilities, like, you can just have text splitters, you get embedding models, so different, vectorization techniques, you can have document loader, data retriever, so all mechanisms that are related to the RAG, retrieval augmentation generation. And then you've got the agent tooling. So agent tooling gives you the capability to access the tool. So for example, if you have a specific type of database, I don't know, if you want to interact with Snowflake, you want to interact with Vertica database, those type of connectors are already in there. Sometimes they need a little bit of tweaking, but they're already there for you to utilize. And then, especially for the prototyping rather than production implementation, you have the LangChain core. So you've got this LCL, LangChain expression language, that simplifies the syntax when it comes to utilizing some of the toolkit that's available there. I wouldn't recommend using expression language for writing production applications, but for prototyping, it is an amazing tool.
Excellent, excellent. Thank you so much, Patryk. And if there are no further questions in the chat, I believe we're almost towards the tail end of the webinar. One thing I did want to mention is during the webinar, Patryk mentioned about 3 different use cases that we went through today. Of course, we focused on 2 of them primarily. One was interacting with the network packet analysis to actually derive valuable insights from the network and track different kinds of signatures and get into depth of interpreting those signatures using the LangChain framework. And Patryk also talked about some of the performance management workflows to track different kinds of KPIs and things like that. So for those 3 demos, actually, we are going to be at MWC, so you can catch us live at Mobile World Congress starting the 26th of February in Barcelona, where we're going to be demoing these applications and use cases in detail. So looking forward to seeing you in Mobile World Congress and interacting with you in person as well. Right? And I think that's pretty much it, Patryk. So thank you once again for your time today. And for all the attendees tuning in here, thank you so much once again. We wish you a wonderful rest of your day. The recording will be made available on the website on www.B-Yond.com. So if you'd like to rewatch it, kindly navigate to that page. I think an email link will also be sent to you once the recording is available. So we appreciate your patience during that. But once again, my name is Anand Ravi, and I'm the Chief Product Architect at B-Yond. And signing off. Wish you all a great day.
Thank you very much. Thank you, Anand, and thank you, everyone. It was a pleasure to be here.
Thank you.
Thanks a lot. Thank you. Bye.